Good afternoon. Thank you for joining us on our call today. My name is Nicole Van Wert Quincy from Transcat, and I will be your moderator this afternoon for our webinar. Our webinar topic is how to improve your maintenance program with a condition monitoring program. The topic is being presented by Alex DeSalle from Fluke. Alex is a product specialist for Fluke Digital Systems. He has 30 years of industry experience as a field engineer working in oil and gas, plus manufacturing industry verticals. He has held various positions as lead field engineer, project manager, and product specialist, SME product specialist, that is. We expect the presentation today to last roughly 30 to 40 minutes, and then we will answer any questions that have been submitted. During any time during the presentation, you can send questions through the question box that is in the right side in your webinar controls. I also wanted to mention that the webinar is being recorded. You will each receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. And at this time, I'm going to turn the presentation over to Alex.
Thank you, Nicole. Good morning or afternoon, wherever you may be joining this webinar. I'm happy to be presenting this today. So let's not delay, let's get started. So now, how can we improve our maintenance program with condition monitoring? And first of all, let's talk about Accelix. Accelix is a Fluke entity. It's all about connected reliability, and that's really the connected portion. Has to do with the data and getting the data from your tools or your sensors, but also has to do with the pillars of reliability maintenance practices as well. Okay. All right. So let's set up the stage here. What is condition-based maintenance? It's a maintenance strategy that monitors the actual conditions via real-time and historical data of the asset to prioritize and optimize what maintenance needs to be done. These actions are performed when there are indicators of potential failure rather than traditional calendar or runtime directed maintenance. So keep in mind that the term condition-based maintenance and predictive maintenance are used interchangeably. A good example of this condition-based maintenance would be, let's say, for instance, we all drive vehicles, and if we're taking good care of our vehicles, we're going to get the oil change or get it serviced on, I'm going to use the word on a regular basis, but what does that mean on a regular basis? What it means for some companies, that even the manufacturer, is bringing that vehicle in for service to do a PM on that vehicle. Let's just use an oil change, for example. So we get our oils changed, and it may say, okay, on a sticker they put on a windshield, let's get that oil change every 3,000 miles. When your odometer reaches a certain value, it's time to bring your vehicle in. Or it could just be on a time-based, calendar-based, saying, hey, after 6 months, whichever comes first. But have we ever stopped to think about when we're actually bringing our vehicles in, we're taking time out of our day, getting an appointment, waiting to sign in, sign out, the amount of downtime on the vehicle itself, how we could be using our time more efficiently, does it actually need to be serviced or not? Wouldn't it be great if we had some indications, other than calendar-based or mileage, that tell us when we need to change the oil? Now, keep in mind, I just want to qualify that and say that, that 3,000 mile oil change is based off of historical data and for the average vehicle, but obviously my point is it may not be necessary to get it. What if we can put sensors in the oil that can measure the oil and look for particulates and things like that, and have that tell us when to go get the oil changed? And on top of that, if we had some sort of nice visual user interface that anyone can understand to tell us when to do that. So what are some of the challenges that teams face today when they try to become more proactive when they're doing maintenance? One common problem is doing more with less, and all of this while the cost of downtime is increasing. So today's maintenance teams, maintenance organizations are strapped, with resources, a lot of changes going on, with automation and things like that. But typically, it's usually in the reactive mode, in most maintenance organizations today. So what are the three main drivers of this? What are the challenges that teams are facing today? It's interesting because before this webinar, I've just got done visiting a customer, and they were mentioning to me he had some pictures on the wall of his maintenance team, and there's a couple rows of pictures, and then the second row from the bottom were ones that had retired, and he was showing me out of the active members are the ones that are fixing to retire, and so what you're talking about, expertise. I quote Henry Ford saying, "Experience is of supreme value in life." So there's a lot of places you go to these days where they're losing a lot of their experienced workforce, and so having to get the filling that gap is definitely a challenge. So shifting workforce. Another maintenance challenge is that things are getting a little bit more complex than they used to be. We're talking about the way technology is going these days. We're seeing a lot more motors that were continuous run or on off are now becoming it's more efficient to run these off of VFD drives or variable frequency drives. So now we're seeing a lot of automation occurring, as we were talking about earlier. And again, teams are getting smaller and they're becoming a little bit more cross-functional. And lastly, budgets are reduced. There's company-wide restraints, and usually a failed program is nothing worse than a failed program, and prohibiting from future funding. So what can maintenance teams do today? In an ideal world, maintenance would be done before downtime. Again, think about we're talking about driving our vehicles before. That what's the key of getting that oil change? We know it's not optimized to trying to do it off the sticker when it's telling us to. At the same time, we want to rely on our sensor to tell us when to get the oil change, but we want some planning involved as well. So being able to predict, schedules, if we can get safer work environments, we get more uptime than profits, more reliability, longer machine life, then we're starting to get to where we want to get to. So let's think about the different types of maintenance strategies that are typical in today's world. The first one is reactive, and this is commonly known as a run to failure. And it's typical. The same customer I was at today, they had a critical asset, and they had what they call a critical replacement motor. And because of the application they'll actually run it to failure. But they were talking, the ideal way to do that is be able to predict when that's going to occur. So being reactive on maintenance is not a good place to be. This definitely can cause some problems or some headaches for many, and when you're dealing with these critical assets that must be up and running. Otherwise, you're talking about loss of production and possibly even safety issues. The second strategy is preventative, and this customers have thousands of assets out there to fall into different categories, and there's many that they do the preventative maintenance on, like we're talking about that vehicle. And if you have, one car is one thing to bring in your vehicle, but imagine you had 3,000 of those vehicles, and you're actually getting 3,000 oil changes that you really don't need to have at that point in time. So many times that there's no, we're working on machines that have no faults or no issues at all, and we end up, working on 85% of machines fall, 85% of assets generally fall into this category. It's just not a very efficient way of doing maintenance. And the third one is predictive. So how do we become predictive? When you think about predictive, there's a component in there, in that word, that needs to be understood, and there's a historical aspect. So you say, what's he talking about? Predictive, historical. Well, to become predictive, you have to have some history. Think about the stock exchanges, how they try to predict stocks, and there's a lot of mathematics and that involved, looking for trends and things like that. But really, the quality of data that you have, and using that data, there's a lot of data out there, but how useful is that data? Again, we get to the quality of data and the usefulness of that data. For example, let's suppose we're able to understand what normal operating conditions are, and let's just use a simple measurement like temperature. Normally the temperature, coming through this pipe, and we got water flowing through the pipe, let's say, normally it's at 75 degrees Fahrenheit, and it's been that way for the last 3 years. In that case, if we're trying to control that temperature, we always want it to be there, then we can start by condition monitoring, we can take route base or use a sensor to tell us when we're going to trend off of that baseline, and that's going to get us the opportunity to react right away. Now back on the car analogy again, we're talking about an engine oil light coming on when it's too late. That's but there's other indications that when you think about analog gauges will start, if you're actually looking at an analog gauge instead of digital light saying that you're over temperature, you can actually see the temperature rising. So this is what I'm talking about. You're starting to notice that, my temperature's getting increased in my vehicle, my radio's getting too high, I better do something about it. So, this is what we're talking about, predictive maintenance. Okay, so what are some of the top questions maintenance teams ask about, condition-based maintenance? One is, how do we monitor all the critical assets in the plant with fewer resources? 2, how do we bridge that skills gap? 3, which tools should I begin with? 4, how to get the benefits of proactive maintenance without a big program. 5, how do we justify the cost of these tools and resources that are needed? 6, how do we start a maintenance program when we're already 100% busy? We're resource challenge, and we're already doing PMs and corrective repairs. And lastly, number 7, how to start or restart a proactive maintenance program. So here's some of the solutions that we can talk about to those questions, some answers to those questions. First of all, let's look at this may look familiar to a lot of people in the audience, but this is a failure curve, potential failure curve, and what we're seeing right here is we see predictive, preventative, and failure, and we see how different technologies can, where they fall into that category, for instance. So talking about, let's say, looking at a motor, for instance, if we look at where it's on the upper portion of the curve there, up on the y-axis at the very top, we got some numbers on the curve itself. 1, 2, 3, 4, 5, and those correspond to different technologies. What's interesting about it, if we see on a preventative side, we see 1 and 2 there, and on the failure side, the bottom line is we don't want to catch things way down in this curve before it's too late. When you think about it, if we're let's say we're looking at temperature of a motor, and we're using thermography for that, or maybe just a contact sensor, if that motor temperature gets too hot around the bearing, and in many cases it's too late, because it's already got the friction off that bearing, the bearing's already worn, and we already seen there's a problem. But so the bearing could have actually been changed, or some action's been done before that. So there are ways and there's technology out there that can be applied and to get us more predictive and not in a run to failure mode. So we can talk about some of those. And before we do that, let's talk about a maintenance strategy. And this is it's easy to relate this type of thinking or this conversation when we think about the medical industry. And we know, of course, we all can relate to that. So let's, think about the case where if we go in for a yearly checkup or yearly physical, the first thing we do, we get in there, you're greeted by a person, and let's say it's a nurse, and the nurse is going to take some vital, readings. I say vital readings. These are indications. These could be analogous to, temperature. Let's say that blood pressure, your weight. So let's just say the blood pressure, for instance, could be a vibration measurement. So from the very beginning, the nurse is taking your blood pressure, and at this point in time, we have a nurse. So it's doing some screening, and you might hear a response, "Hey, your blood pressure is looking good today," or you might hear something like, "Uh-oh, you're borderline." In that case, I think you should come in more often. When you think about you going in for a yearly checkup, it's of course, we know how we feel, right? But we're going in for a yearly checkup. We're trying to catch things before they happen. We're seeing that, oh, we never knew our blood pressure was higher than what it should have been. We might have think we felt some symptoms, but it took that visit to do that. But now, since our blood pressure is borderline, it's like, okay, we want to see you more often. So when we walk in there, I would say that's analogous to a route-based measurement, or just taking a handheld tool, taking a reading. But notice what the nurse is doing. That reading is actually getting recorded into a system, and it's getting compared against some standards. So right there, you're actually taking that data, instead of just looking at the blood pressure monitor doing a verbal thing, it's being actually entered. And after a few years of going there, they can actually pull a trend on some of these things, like your weight, for instance. Am I trending? I'm getting, I'm starting to get heavier. I'm actually losing weight, or my blood pressure is increasing. Okay, so sticking with the blood pressure conversation, let's suppose the nurse measures your blood pressure, and your blood pressure is starting to it's really above the threshold that's starting to get worrisome. It might be right then at that point in time, it's so high that the nurse says, we need to call a doctor in here. So what am I saying here? We have a nurse measures our blood pressure. We know it's high. So really the nurse has done some screening. And there's tools out there that are designed just to do screening. But we don't know what the root cause of that blood, why our blood pressure is high. It's going to take someone, or a tool, or a doctor, who could diagnose that problem for us. So the blood pressure is high, but what's the root cause of that blood pressure? What's the cause of that? And who knows, it might even require specialists to really get to the root cause. Ultimately, we want to do a root cause analysis and get to the root cause, but the point I'm trying to make when we think about our maintenance program is that we're not going to go in and see the specialist right from the very beginning. We're going to do some screening ahead of time. And this is one of the approaches that we can take in maintenance. We don't want to take the analysis tool out there to do screening work, or where it's going to take someone's expertise, of which we may have limited resources that actually have that expertise to do that kind of stuff, limited bandwidth and certain skills, for instance, thermography and vibration, for example. We're not going to take this person with a skill set and this analytic tool to go out and do PMs with. So we can take this approach to optimize our maintenance practices. If we look at a typical, or let's explore this workflow a little bit further, and we could see that if we start thinking about the types of assets that we have in our facilities, and we start thinking about in tiers, what we would call critical assets. And if there's a few examples of those, a turbine machineries, or assets that could cause the loss of life or injure someone, at the same time could bring the whole plant production facility to its knees if it goes down. These definitely require these are high level assets for monitoring. But there's hundreds of thousands of other type assets that kind of fall into the lower category, like pumps, fans, blowers, compressors, those type of things that don't necessarily need that type of monitoring. So if we see at the very bottom there, we're going to start screening our assets, much like we're talking about where the nurse goes, and when we go see the nurse before we go get referred to see the doctor or a specialist. And then we just follow a decision tree right there. Is our blood pressure fine? Is our blood pressure within the limits? Then we're done, and so there's no further action. And so we use a simple screening tool like a blood pressure monitor that doesn't take a lot of analysis to really get us a quick answer, as opposed to like doing an EKG, which definitely needs someone with a skill to understand what that data is telling us. But let's suppose we see our blood pressure is high, we go up, and that's when we need to diagnose. Is it an easy repair, or do we need to get that specialist in? Okay, so let's kind of recap. Let's talk about these steps again. What the steps we want to do for total condition maintenance in 4 simple steps. First one is we're going to screen our machines to find out which ones are good or bad. Then we're going to diagnose any machine faults we come across to try to get some sort of root cause analysis. Of course, we want to correct them. you know, it's interesting when you think about motors and that have couplings or driving maybe some belt-driven fans, for instance, or direct coupled to pumps and things like that. It's amazing how many of those systems out there you find are misaligned just from the very beginning. And with that misalignment, you know, it could actually be causing some bearing wear that's completely unnecessary. So, but the point about it is that we actually want to go through the entire process, screen, diagnose, and make the corrections, but don't assume that everything, like for instance, everything is what you're going to call a standard normal operating conditions. There's definitely a lot of thinking that goes into that to make sure that, yes, you know, everything's are aligned properly, but if we see a problem, let's correct it. And after that correction is made, go back and check it. You know, go back and make sure that the corrections made were done, you know, and document that. Okay, and then where do we focus our energies at, you know, in the facility? You know, a lot of critical assets, but if you notice in here, there's components of this particular facility that have dollar signs, some more dollar signs than others. You know, energy is a huge cost in a lot of facilities. So let's identify what areas of facilities are a big cost, you know, where are our cost savings at? And, you know, again, those critical assets, but also the ones, some of those assets can become critical just because it costs it takes to operate them and the downtime that we see. So, and let's keep in mind too that it's not just any one technology. The idea is that many times it's a combined technology that can lead us to a proper diagnosis or get us to where we want to go as far as being, you know, predictive. For example, our blood pressure is high. At the same time, we have a high temperature. You know, because the nurse took the temperature and noticed that the blood pressure and the temperature is high. Well, there's definitely something wrong there. So that's more data. You know, yeah, with the temperature high, you're actually in feverish, you know, with high blood pressure. So having more indications that on one particular asset, a component asset being a human being, but let's say a motor, if we're looking at vibration, there's other things that we could look at besides mechanical, you know, that there's electrical components to that motor as well. And so if we actually looked at the quality of power coming in that's driving that motor, you know, if we know that motor's being operated properly within the application limits, is it spec'd properly? There's a lot of things that we can do to become more efficient, and how we can combine technologies to help us, you know, to help us identify problems with equipment. So another tool that we can use is a lot of tools can produce reports, and again, a lot of tools can produce trending data. So, for instance, on a handheld measuring tool, you know, if we want to set up that tool and take a route-based measurement, and let's say we're doing this once a week on a particular motor, you know, after about a year's time, we're going to have 52 weeks or 52 data points in that motor. It's amazing. You know, I have visited many customers that do have a route-based vibration program, and they're taking the reading with the vibration meter, and what they're doing is they're writing it down, or not even writing it down. They're just kind of like checking a list, saying, hey, this one checked out okay. You know, it's kind of like you're going to see the nurse, and your temperature, let's say your weight, you know, after 10 years you've always had a certain particular weight, but all of a sudden you have a weight gain. How are you going to notice that weight gain? Do we actually remember things like that? You know, but if we start to see something's changed, you know, we start to see a change in the data. Why is that? What's the assignable cause for that change, you know, in that data? So again, the data can become a powerful tool. You know, if you have the tool already, what's the point we're trying to make here? It's like, get that tool connected to some sort of connection to a program, a CMMS program, or some kind of enterprise asset management program, so we can store that data. Now, when we use these tools, we make sure that we want to set these up tools properly. You know, everyone's heard the terms garbage in, garbage out. So if you're not setting the tool up properly, obviously you're not going to get the results you want. Let's take some measurements and let's try to be, repeatable how we take those measurements. And then, if we get to the point where we have to diagnose problems, let's take full utilization of the diagnostic tool using the reports, and many tools can actually produce a report that gives you, recommended actions to take. So an example here, we're talking about a screening tool, applying the maintenance, the process we were talking about before, the strategy of screening, diagnose and correct. We can actually use the data coming out the each one particular tool for that function and optimize our maintenance practices. So I guess the point I'm trying to make right there is that many times that data is right in front of us, and it'd be surprised at the maintenance teams out there and different facilities and different verticals that how that you might find that the data is just not making it into any sort of a computerized management system, or that it's like they have the right skill set, they have the tools, but is that data actually being connected or being captured? So how can we, how do we justify the cost of these tools? It's like, okay, this all sounds good. Yeah, I definitely want to get, use condition-based maintenance and want to start doing that. But how can I start doing that? How do I go to management or whoever's making the decision makers help justify some of these costs? Well, one of the arguments is, hey, we can save production downtime, obviously. We can actually start. If we think of that building we're looking at earlier, identify where wasted energy is. We can use tools that can tell us that information right off the get-go. What's the replacement cost of machinery? And the other thing about that is that how accessible are replacement parts for that particular machinery? Obviously, there's a maintenance and labor costs, and keep in mind when we say maintenance and labor costs, we're not just talking about the cost to repair when let's say a motor goes down or bearings have to be replaced. This also includes the preventative maintenance strategy that we're talking about earlier, bringing our vehicle to the oil change facility to get that service done. There's a cost associated with that. We have to pay that out of our pockets, but at the same time, we're taking our time from our day, and that asset's down. And lastly, what do we mean by outsourcing third-party costs? What I mean with that is that if let's say some facilities don't have a vibration analyst or some sort of expert there, or any sort of thermography program, what you'll find is that they'll contract that work out to third-party providers. One of the pitfalls of doing that sort of the outsourcing is, number one, you can save those costs, right? But the other thing too is that when you think about it, when someone let's say we contract out our vibration to a third-party company, let's say they're measuring 17 different assets, what are the chances that all 17 of those assets are running under normal operating conditions? So we're collecting data, it's all well and fine, but let's say 5 of those particular assets or the machines are not running under normal operating conditions. And if you look at the data over a period of time, you can't make that assumption. It could be that maybe there was on a VFD drive and it was running at 5% as opposed to 95%. So yes, I'm going to see some difference in my data. At the same time, though, it could actually be locked out, tagged out. So maybe it's not even operating. So it's going to miss its its contractual obligation at that point. So how do we do this? What we've learned is that if we start small and grow, when I say start small and grow, we have to figure out optimize which assets we want to start small and grow with. And so just a quick, asset criticality assessment, it can, is in order so we can actually make the right decision on how we can show, our management decision makers that hey, this is the way to go. Start a pilot program. Show some success on some of the machines in a small area, and then kind of expand it further out into the plant. Reduce some of the PM repairs. Start looking at the data. Start the screening approach we talked about earlier on maybe 25 or 30 machines, and now later on you can add more machines to the program. And then always go back and reevaluate your program. Review a machine should have been trended for fault conditions, and you'd be amazed at what the data can tell you. So when you trend a few machines, reduce the number of PMs and repairs. Now you have more time to add machines to condition monitoring. Okay, so how do we start a new PM program? How do we begin that? Well, you don't want to start big. The key here is to start small. Use the approach we talked about earlier, and do the screening, as we talked about screening. But start small. The next one is make sure you have the right technology selection, and make sure we match the right skill set or resource to that technology selection. Some of these technologies you just can't use right off the shelf without some sort of knowledge in, like, say, thermography or vibration. But these days, many tools actually have the analyst built in. So if we actually use that tool properly, we're going to get the results of the analysis that we want based off of the what's built into that particular product. So make sure we use the right technology for measurement. And the last one, and very important, is our data management. This always gets overlooked, but and there's a lot of talk about IoT out there, a lot of data. It's not the amount of data, it's the quality of data. Data's no good if it's not really doing anything for you. So, if we're just capturing the data and we're putting it in some sort of program, but we're not actually, going back and looking at that or finding a way it can be useful to us, what's the point in that? On the flip side, there's a lot of facilities out there that have data there, and they have a lot of indications there that just if we actually looked at it properly and grouped them together, and we can actually get a lot of information that's already there we didn't even know about. Okay, so that's what we're going to talk about here, is that teams have to be able to use the technology, and many times it's a mix of that technology and the data, and we're going to call it actionable data. The data we can make decisions on for our maintenance strategies. For example, let's suppose we're taking a vibration reading and we got a handheld unit. If I have some thresholds built in or some sort of alarm strategy built in that unit right there, that if I take a measurement, it's telling me yellow or red, that hey, this is not acceptable, or we're kind of in a yellow zone based on the indication I'm seeing for this particular machine type. Right there, from just taking that measurement, we're getting actionable data. For instance, a blood pressure monitor, what we talked about earlier, when you go to see your doctor on an annual visit, a nurse taking your blood pressure, that data is actionable right off the bat if it's above the threshold. But what are some of the barriers that can frustrate the data collection? For instance, the maintenance team position and reliability journey. I'll jump to the very bottom there, where on that point where it talks about culture change. One of the biggest challenges I see out there is actually the culture. There's a lot of thinking in that maintenance, reliability engineers and people involved in the reliability world actually want to put these processes in, but you got to have the culture to foster. Like use an analogy of a tree. A tree will grow in the right environment a lot faster as a tree not growing, let's say, above the timber line on high up on a mountain. So we have to have that culture to really foster this type of to get into that reliability world. And also another thing we run into is that that data's there that I was talking about earlier, but many times it's siloed. There's a lot of systems out there that, or let's just call it multiple systems, that may be associated with a particular sensor manufacturer or whatever, sources of information that might be siloed by department or within the particular a particular motor type that we're not sure about, but if we can compare that same motor type in the same circumstances against maybe 10 or 20 other motors doing the same thing, we can draw better conclusions. And take full use of if you have a handheld tool, if the connectivity that we talked about earlier is a key component of that. So we can make good use of our handheld and our wireless sensors and other technology and software that can actually automatically aggregate this data for us. And this is what we were talking about earlier with the connected reliability framework. So for example, asset management, enterprise asset management programs, or CMMS, computerized maintenance management software. These systems are definitely great tools for us, aggregating the data and getting actionable data. But that includes sources from all types of sensors. So if you have that you're using, and earlier we talked about using the right tool for the right job, keep in mind with any particular system, there could be indications that are associated with that system we can always use to help us understand or diagnose problems. There's HMIs out there that have indications that are running, let's say an air compressor unit, for instance. I can see what my standard volumetric flow rate coming out that unit is. There may be some temperature indication there, pressure indications, in addition to the tool that I'm going to be using to do some troubleshooting. Okay, so I want to thank everyone for joining the webinar, and that's the end of my presentation portion. So I'm going to turn it back over to Nicole right now. Nicole? Okay, folks, might be having some technical difficulty waiting for our moderator to join in. Okay, team, apparently our moderator is not able to unmute herself, so please bear with us. so we can answer some of your questions. Maybe you could, it's possible to type some of those questions in. And give her about 30 more seconds here, and I'll take some questions here. Okay, and well, team, I just got a reminder from our moderator who was having a technical difficulty, but I do want everyone to know that this presentation is being saved and will be sent to everyone that joined in on it today. And I got some questions here that I can answer. All right, Nicole, we're seeing your screen here. Okay, so I got a question here. It says, we don't have wireless in our buildings. Can we still use condition monitoring tools? The answer to that is yes, you can. If your tool, if the data from that tool can make it into a computerized maintenance management program or an enterprise asset management program simply by manual entry. So we can use our handheld tools to go take a reading and enter that data, or many tools have the capability of storing that data, and then when we do get connectivity with that tool, we can actually upload it once we get into an area that we have connectivity. Okay, another question we have is, we already have fixed sensor on critical equipment. Is that enough data for a strong predictive maintenance program? That's a very good question. If we got fixed sensors on that maintenance equipment, chances are, and the question was critical equipment, chances are there's a reason why those sensors are there. Is it enough or not? It really depends on what that data is telling us. So what we should do is review that data and see what it's telling us, but keep in mind that there could be other indications that can augment those fixed sensors that are on that equipment, or even from route-based tools. I want to stress again that when we think about condition-based maintenance, it's not all about wireless sensors and being connected, getting nonstop readings. Many times it's a combination of a handheld tool, which is connected and to some sort of system, where we can at some point get that data from that tool into a system, in addition to sensors that may be associated with that critical equipment. Okay, another question. We operate in mostly a reactive workflow. The thought of jumping in predictive condition monitoring tools seemed like a big leap. What are some of the steps we can take? What we talked about earlier, some of the steps that we could take are steps like starting small. Don't try to do the whole facility. But it's really about trying to find a good example. Let me back up a minute. One of the first steps you can take is really identifying the culture and where you're at on that journey. We have to be able to, it's amazing that where I've seen successes in condition-based maintenance, is where they've had the culture there. Someone's actually been a driver or a champion, early adopter, whatever you want to call them, but driving that culture. At the same time, identifying the right asset to start with, and then showing some good examples, some case studies that they can show devices onto our network. That's a very good question. So how do we work with our IT team? Well, many manufacturers that are in that world that have connected devices and they want to get on a network should have some sort of a network configuration requirement spec sheet that comes with them. And so it's just basically a compatibility thing. What's required from my IT department to get me to be able to use this tool? And what we'll find is that being product agnostic, many people in this world that sell these products will definitely have the data sheet or the information that an IT person needs to allow it onto the network, like opening some ports and information specific, to the network, even in security things, encryption, things like that. Okay, and here we got another question. My boss wants to reduce the downtime but doesn't want to invest in predictive tools. How do I convince him that we need these tools? Well, that's a very good question. We kind of answered that earlier. One is doing a case study in the way that we talked about before. Of course, there's nothing more convincing than timing. If we do have a critical asset that went down or run to failure, that's a good time to bring that subject up. Hey, by the way, this pump I'm replacing or this motor I'm replacing here, this is the the third time in 5 years we replaced this, and look at what it's cost us. So really the data's there, or the experience is there, but sometimes it's just a matter of doing it at the right time, that right moment, this now, and it's because that's when they listen. When it's costing them money and costing a particular company money, that's when decision makers listen. After things are repaired, everything's running normally, it's all fine. And so when we think about our cars, and going back to the car example, when we think about that, as long as the car's running, we don't care about, think about the run to failure scenario on that. You don't bring your car in for an oil change, ever. But then all of a sudden, your car fails on you, and now you're stuck in the middle of the highway. I think at that point in time, the driver of that vehicle is going to start thinking, hey, wish I would have been, instead of run to failure, preventative on this. Or they may even start thinking about becoming more predictive on it, even, especially depending on the amount of pain it causes and where they get stranded at, or the cost of running that vehicle to failure. So it's really it's not complicated in that case, folks. Okay, I'm not seeing any more questions appear at this point in time. We'll give another couple minutes for any more questions. If we don't hear any more questions in the next couple minutes, we'll just go ahead and let everybody recover some of their time of their day. Well, okay, looks like we got all the questions answered. I want to thank everyone for attending the presentation today. It's certainly my pleasure to talk about, you know, reliability, maintenance, and especially connected reliability, Excelix, and to do these type presentations, and especially watching maintenance teams switch from being reactive to preventive to more predictive or condition-based maintenance type of program. So again, thank everyone for joining us, and we'll say goodbye for now.